So this is our second lecture. We have started with the last week on Friday itself. So the first lecture that I have covered was all about nuclear physics, previous year question that came in gate examination. So today I'll cover a question from quantum mechanics. Okay, let's just start. So this was a question. It is for 1 marks. It is of 2016 examination. So in this question, I'll read the question first. So in this question, a two-dimensional square rigid box of length L contains six non-interacting electrons at T is equals to 0 Kelvin. The mass of the electron is m. The ground state energy of the system of electron in this unit you have to find out. So first of all, before proceeding for this question, here in the question you are asked a 2D square rigid box. 2D square rigid box. Okay. So in quantum mechanics, you know that if you want to specify, suppose there is some particle, this is some particle. If you want to specify about the dynamics of this particle, so you should solve the Schrodinger equation, right? Yes. So after solving this Schrodinger equation, what you will get? You will get energy levels and wave function of the particle. The wave function and energies that the particle are occupying. Now coming back to the question. In question, you are given a square rigid box and it is 2D system, huh? It is 2D system. How many of you are aware with particle in a infinite square well potential? How many of you have you done?
Yes,
Okay, right. So you have you have solved Schrodinger equation for particle confined in an infinite square well potential. Do you know the wave function and the energy level form for that system? Anyone? E is equals to n square. Up, correct. And psi n pi x y, right? This is the form, na? This is the form, but this is for 1D. This is for 1D. But in question, what you are asked? 2D, right? We will solve Schrodinger equation in 2D. So it's a very easy question. Just why I have written R, because R is defining there are two dimensions, right? No problem, na? Till this part there is no problem. If in question it will they will ask like for three dimensions, so you will write R is square is equals to x square y square and plus z square. But in question it is 2D, so we'll solve this, and it's a very easy equation. When your potential is independent of time, so you can write v xy is equals to vx plus vy, and same goes for energy. We will use which method to solve this Schrodinger equation in two dimension? We will use separation of variable method. When the potential is independent of time, then we can then energy can be written as energy of the overall equation can be written as sum of individual axis energy, and wave function is the product of individual wave function. So you should keep this thing in mind. This is very important. Okay, now apply the same thing here. Minus h cross square upon 2m d2 psi is, we can write psi x, and psi y will not come inside because psi y is constant for this differential, right? So psi y will write outside, plus v psi x psi y goes to e, right? Now solve this. This is very easy. Take this e psi to the left hand side, minus h cross square upon 2m d2 psi by dx square 1 upon plus v is equals to e. Okay, any problem? Yes, say what? Okay, 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 okay. So I'm solving for one only, one variable only. Okay, okay. I got. So there will be one more term. Yes, there will be one more term. Minus h cross square upon 2m d2 psi y by dy square. Yeah, there will be one more term. And psi x. Yes. So then after that, after solving this all, at the end you will get two Schrodinger equation. One in x-axis minus h cross square upon 2m d2 psi x by dy square plus v psi, and ex why I am writing, because energy can be written, the overall energy can be written as the individual sum of individual energy, and the other one you will get minus h cross upon 2 d2 psi by, sorry, this is x, dy square plus v psi y ey. And this equation, how to solve this. You might have done this equation for particle in a 1D box. So particle in a 1D box, you have solved this equation, right? Because when this particle is 1D box, so the potential for this one is 0, right? So when we have solved this equation for one dimension, so in that case the equation was minus h cross square upon 2m d2 psi by dx square plus v psi is equals to e psi. Okay, for one dimension. Then what we have written, d2 psi by dx square minus 2m upon h cross square v psi is equals to minus 2me upon h cross square psi, and v is 0, right? So this term will go to 0. Then d2 psi by dx square is equals to minus 2me upon h cross square psi. Then solve this equation. How you will solve this is how you will solve this equation. This is the differential equation, right? And you know the solution for this equation. I'm taking it as a k square. So d2 psi by dx square plus k square psi is equals to 0. So the solution for this differential equation is psi is equals to a e raised to the power eta kx plus b e raised to the power minus eta kx. This part you can read it from mathematical physics. In mathematical physics, when differential equation chapter was there, so in that chapter there was one question, how to solve the differential equation of these kind, right? Of this particular kind. Now, psi I got a e raised to the power eta kx plus b e raised to the power minus eta kx. So I can write psi is equals to, can I write e raised to the power eta kx is equals to a cos kx plus eta b sin kx, right? Any problem? Huh. So any this is constant, so I can write any term like c cos kx plus eta b, not b, d sin kx. Again for this one, b is equals to uh, b is equals to e, no, e cos kx plus sorry, minus, minus f sin kx, right? Then sin x is equals to a is equals to I'll take these cos kx term on one side, so c cos kx uh, plus b e cos kx, okay, plus same way, take eta term on another side. These will not come. Take eta term on other side, like b, wait, I'm doing wrong. This will be sin a e raised to the sin a e raised to the power minus eta kx plus b e raised to the power eta kx, okay. Then you can write a is equals to cos kx minus eta sin kx, okay, and b is equals to cos kx plus eta sin kx. Take cos term on one side, cos kx term on one side, a plus b is equals to cos kx, right, plus a minus b is equals to eta sin kx, right? Any problem? So I can, yes, say, okay. Then this I can write a sin kx. A I'm taking because it is a constant. A sin kx, and this I can write as a b cos kx. This is a constant. Don't get confused. I can write also write it as a dash. A plus b is equals to a dash, and a minus b is equals to b dash. Okay. Don't take anything why a again you have taken a. It's just a constant. Then now we'll apply boundary condition for particle in 1D square weld potential. So you know in boundaries, x is equals to 0 and x is equals to a, wave function should be continuous, right? So phi x0 is equals to phi xa, and d psi x0 is equals to d psi x is equals to a. This is the boundary condition, right? After applying boundary condition at x is equals to 0, so phi 0 is equals to, this term will go 0 because x is 0, and b cos 0 is equals to 1, so b is equals to 0, because psi wave function is continuous, should be continuous at the boundary, and it is going 0 at boundary, so b is equals to 0. Applying b is equals to b value in psi x, so we got wave function is equals to a dash sine k x, okay. Now we have one more boundary condition, and that is psi x at a is equals to also 0. So apply this one boundary condition, you will get 0 is equals to a sine kx. This a will go to left hand side and it will become 0 sine kx is equals to 0, and sine kx is equals to sine n pi. All the value of sine n pi, 0, 1, 2. If you put all the if you put value of n, 0, 1, 2, pi, then sine 0 is 0, sine n pi also, sine pi is 0, then sine 2 pi is 0. So in a way you will get kx is equals to n pi. Okay, and x is equals to a, ka is equals to n pi, and you will get k is equals to n pi by a, and psi is equals to a dash sine k x by a. That means a sine n pi by a. Similarly, how to find out energy? I have written here that k square is equals to 2 me upon h cross square. In this page, in this slide, I have taken 2 me upon h cross square is equals to k square, right? So from that, just rearrange it. K square h cross square upon 2m, and put the value of k, it is n square pi square h cross square upon 2m a square. Okay, so this is the value for 1D. And for 2D, for 2D, wave function of 2D is equals to wave function of individuals, right? So phi xy in 2D is equals to root 2 a, root 2a sine nx pi x by a, and sine ny pi y by a. This will be wave function for 2D system, and energy will be nx square, because we are taking both the dimensions. Okay, and ny pi square h cross square upon 2m a square. Okay, so this will be energy for 2D system for particle in 2D square potential. Now I can write it also nx square plus ny square pi square h cross square upon 2m a square. No problem till now. Now we will go back again and read the question, what is asked in the question. So in the question, we are asked to find out the ground state energy of the system of electron in this unit. Okay. So just now we have found out the energy formula. It is nx square plus ny square pi square h cross square upon 2m a square. So in this case, a is L. So L square. Now you should find out the ground state energy of 6 non-interacting electron. So it's very easy. We have system of 6 interacting electron. So this is the wave function. This is the state for this system. There are 6 electrons and they are non-interacting, right? So only two electrons can occupy each state, right? This is the Pauli exclusion principle. No two electron can have the same set of quantum number, right? So in the case of electron, s is equals to 1 by 2. Okay, so 2s plus 1 is equals to 2 into 1 by 2 plus 1 is equals to 2. So that means each quantum state can be occupied by only two electrons, right? So now we will fill these 6 electron in this quantum state. So nx ny, first we will fill 1 1, right? First state will be 1 1. So in 1 1 state we have two electrons. Any problem? First is nx is equals to 1 and ny is equals to 1. So in this state we have two electrons. Okay, now the next, yes, any, okay, now the next state will be nx is equals to 1 and ny is equals to 2. But I can also write it nx is equals to 2 and ny is equals to 1. So what you understand from these 2, from this, like I can, Degeneracy, yes. So in this state we have degeneracy. So there it is 2. The degeneracy is 2 for nx is equals to 1 and ny is equals to 2. So there will be 2 for nx is equals to 1 and ny is equals to 2, and there will be 2 electrons for nx is equals to 2 and ny is equals to 1. Now find out E is equals to, E will be, first is 1 1. When nx is 1 and ny is 1, so how many electrons are there? There are 2 electrons, right? 1 plus 1 pi square h cross square upon 2 ml square. Now when nx is equals to 2 and ny is equals to 1, again there are 2 electrons. Nx is equals to 2 and ny is equals to 1, again there are 2 electrons. And when ny is equals to 2 and nx is equals to 1, then again there are 2 electrons. So solve this, you'll get 2 plus 5 10. I'm writing it directly. No, it will be 4. So this is 1 plus 1 2 and 2 into 2 4. This is 4 plus 1 5, 5 into 2 10. This is 4 plus 1 5, 5 into 2 10. Pi square h cross square upon 2 ml square is common. So then it is 24 pi square h cross square upon 2 ml square. So what is the answer? Answer is 24. I hope this question is clear to everyone. Any doubt with this question? Okay, so we will proceed further. So this was a very easy question. Like in this question, yes, huh? So you should. They ask for ground state energy. It is true, but you should accommodate electrons in such a way so that you can fit all the electrons. They have not asked you about excited state. When they will ask you about excited state, they will ask you like if suppose you can excite one electron to other energy level, then you have to find some combination. This is the ground state in which you have to accommodate all the electrons. Hello. Now moving on to the next question. This is the next question. So this question, again, if you know the a free electron of energy 1 ev is incident upon a one dimension finite potential of height v naught. V naught is given to you 0.75 ev. And energy of a particle is given to you, that is 1 ev. That means energy is greater than v naught. Energy E is greater than v naught. You have to find out the probability of its reflection from the barrier. It's a very easy question. So particle is striking a particle is striking a step potential. How many of you have done the calculation for it? So solving Schrodinger equation for such a system. Okay, so then it will be very fine, no, very nice, because it's a very easy. It's a first question that we generally do while solving Schrodinger equation for different system. First one is solving the Schrodinger equation for free particle. Then the second one is step potential. Then third is particle in a one dimension box, one dimension infinite square well potential, symmetric asymmetric, two types we generally do. Then the third one is particle in a harmonic oscillator. So this one is also one of the question, and it's a very easy question. So you should, if you are, what? Yeah. I'll summarize them. Okay. So in this question, so it is a step potential. So you have to find out there is this reason one and there this reason two. Okay. Now, you should solve the Schrodinger equation for both the reason. This wave is coming like this. This is incident on this step potential. Some of it will be reflected and some of it will be transmitted. So we will solve the Schrodinger equation for both the reason and we'll find out the wave function and energy levels. Okay, now for reason one. Reason one, we have v is equals to 0, right? So minus h cross square upon 2m d2 psi by dx square plus v psi is equals to e psi. This v is 0. So directly write d2 psi by dx square is equals to minus 2me upon h cross square psi. No problem. So we can write it d psi dx square reason 1. Reason 1. This is reason 1. And I'm taking it as k1. I'm taking it as k1 square. So minus k1 square is v psi 1. And again, I have told you like what will be the equation, what will be the solution for psi for this equation is a e raised to the power eta k1x plus b e raised to the power minus eta k1x. This signifying the incident wave and this signifying the reflected wave. Okay. Now for the reason 2, we have minus h cross square upon 2m d2 psi 2 by dx square plus v psi 2 e psi 2. In this reason, v potential is not 0. Huh? Potential is given to us 0.75 some value, but we have to solve the equation. Then we can apply this. These values are given to us. But first of all, we should know how to solve this. Na? Then d2 psi 2 by dx square minus 2m h cross square no no upon h cross square v psi 2 is equals to minus 2 me upon h cross square v psi 2. Clear? Then we have d2 psi 2 by dx square is equals to what will be the form 2m h cross square, then this will go minus, this is also minus, then this will be like v minus e, right? Psi 2. And if suppose I have taken it d2 psi by dx square is equals to minus 2mh cross e minus v psi 2, then this will become d2 psi by dx square is equals to minus k2 square psi 2. Why this is k1 and k2? Reason being because in first reason we there is was no potential. So in the second reason there is a potential. So it will change. There will be a change in the propagation constant of this wave, and there will be a change in its energy also. Now, what will be the formula for what will be the solution for this one? Psi 2 will be c e raised to the power eta k2x plus d e raised to the power minus eta k2x. So we have solved equation. This is psi 1 is equals to a e raised to the power eta k1x plus b e raised to the power minus eta k1x, and psi 2 is equals to c e raised to the power eta k2x plus d e raised to the power minus eta k2x. This is the incident wave, this is step potential, and this is the incident wave, and this is the reflected wave, and this c e raised to the power eta k2x is transmitted wave, and this d e raised to the power minus eta k2x is reflected wave. Since there is nothing for this wave to get reflected, so this term will go to 0. Okay. Now now find out the reflection coefficient and transmission coefficient. In this question, we are asked only reflection, so I will find out only reflection coefficient. But if you want, I can find out transmission coefficient also. The formula for this one is reflected. You have to find out the reflected current density divided by incident current density. This will give you reflection coefficient. Okay. And for transmission coefficient, you have to find out the transmitted current density divided by incident current density. And how to find out this reflected and transmitted and incident current density? There is a formula for it. Okay. So J incident is equals to eta h cross upon 2m psi d psi star upon dx minus psi star and d psi 1 x upon dx. Similarly, so this is the general formula to find out the current density of anything. And now for if you want to find out for incident one, so what you will write eta h cross upon 2m psi for incident wave. What is the wave function? The wave function is a e raised to the power eta k1x. Psi incident is equals to a e raised to the power eta k1x. So psi incident star is equals to a e raised to the power minus eta k1x, and psi reflected is equals to b e raised to the power minus eta k1x, and psi reflected star is equals to b e raised to the power plus eta k1x, right? Psi transmitted is equals to c e raised to the power eta k2x, and psi transmitted star is equals to c e raised to the power minus eta k2x. Okay. So d psi star by dx, that means you have to find out the d psi star dx of incident wave. So it will be a eta k1, minus eta k1 e raised to the power minus eta k1 x minus a e raised to the power minus eta k1 x, and you have to find out the d psi by dx of this one, k1 x. Eta h cross upon 2m, this will become uh, this will become a square, this a square, this will go cancel, minus eta k1, again this will cancel, this means e raised to the power minus eta k1x plus eta k1x is equals to e raised to the power 0. So e raised to the power 0 is equals to 1, so that is why I'm saying cancel eta k1. Okay. And this will become eta h cross upon 2m. This is minus 2a square, and this will become eta square, right? Eta square k1. So you will get this 2 will cancel each other. We have h cross, a square k1 by m. I think this we got j incident. Now you have to find out the j reflect current density for reflected wave by yourself. So I'll give you what it will come. So j reflected, huh? Eta square, not I. No, this is I, and this is the here is one more I na in the outside. So I eta square. So eta square is equals to minus one, and there is minus. So minus minus plus I square. Yeah, I square. So I square will be minus one, na? Okay, I'll solve. So this is eta h cross upon 2m, and from inside we have 2. This is minus minus will come outside. A square eta. Sorry, this is not eta square. This is K1. Okay. Then this 2 will cancel each other. This iota square, and this is H cross. This is A square K1 upon M. Right? Iota square is minus 1. We have already minus outside, so it will become plus 1. Then this is H cross A square K1 by M. Got it? Any problem? Okay, so your task is to find out the reflected current density. It will come out same. It will the only thing that you have to put psi r. Psi r is b e raised to the power minus iota k1 x. So in the formula for reflected current density, the formula will be J reflected is equals to iota h cross upon 2m psi r d psi r star upon dx minus psi r star d psi r by dx. That's it. And you will get at the end minus h cross km upon m b square. And for transmitted you have formula I h cross upon 2m psi t d psi t star upon dx minus psi t transmitted wave function and d psi t upon dx, and it will come out h cross k2 m c square. Okay, I hope they should be. Actually, this is the formula for finding out the current density. And I'm not solving this formula in the class because this is the straightforward formula. This will come when you will solve Schrodinger equation. In the first, okay, I'll tell you from where I got this formula. So, Griffith for quantum mechanics. In the first chapter itself, this formula was derived in Griffith. Huh? Huh. This is oppositely directed. Yes. This is the current density, yes. For reflected wave, it is negative. So it is just defining the sign of like direction, I can say. Now you have to solve the equation, na? So apply boundary condition. Psi 1 is equals to a e raised to the power iota k1 x plus b e raised to the power minus iota k1 x, and psi 2 is equals to c e raised to the power iota k2 x. So psi 1 is equals to psi 2 at x is equals to 0, right? And d psi 1, this is the boundary condition. Dx x is equals to 0 and d psi 2 by dx at x is equals to 0. This is the boundary condition. So when I'll apply first boundary condition, so a plus b is equals to c, right? Any problem? And now for the next boundary condition, d psi 1 by dx, first of all find that iota k1 x plus b iota k1 e raised to the power minus iota k1 x, and d psi 2 dx is equals to c iota k2 e raised to power iota k2 x. Again d psi 1 x by dx is equals to d psi 2 by dx for x is equals to 0. So we will get iota k1 a plus nahi, minus iota k1 b is equals to c iota k2. So these are the two equations, and you should solve these two equations for finding out C and B in terms of A. So first equation I'm finding out C. So I'll multiply it with this iota will cancel, na? This iota will cancel from both the side, right? So it will be K1A minus K1B is equals to K2C. So if I have to find out the B, so what will I do? What will I do for finding out? I'll multiply it with K2, right? So it will give me K2A plus K2B, CK2, K1A minus K1B is equals to CK2. Minus, minus, minus. So K2 minus K1A is equals to uh, k2 plus k1 b is equals to 0. So if I'll take this to that side, so k2 k1 b is equals to, I'm taking a terms on other side, so it will become k1 minus k2 is equals to into a, then b is equals to k1 minus k2 a by k1 plus k2. Okay, and you know very well that your reflected current density, the reflection coefficient, just now told you that reflection coefficient is equals to j reflected by j incident. And what was the value of j reflected? H cross k1 upon m a square minus h cross k1 upon m b square. Yeah, you should. Okay, sorry. And you should keep this thing in mind that it is the modulus. So this negative sign will not affect anything. This is just we are taking the modulus of it. So this will cancel, and we have upon a square. And just now I found out b by a. What is the value of b by a? This is k1 minus k2, k1 minus k2 square upon k1 plus k2 square, right? But in question we are given e and v. So what? How you will transform k1 and k2 into e by v? In the starting itself, I told you that k1 square is equals to 2me upon h cross square, and k2 square is how much? 2m upon h cross square e minus v, right? So just apply this one. K1 is equals to 2me upon h cross square, and k2 is equals to 2m e minus v upon h cross square. Put this value here, 2me upon h cross square minus 2me minus v upon h cross square, right? 2me upon h cross square plus 2me minus v upon h cross square. So this whole square root. Okay. Yeah. Sorry. Yes. This will be square root. Yes, this will be square root. Yes. Huh. Then all the term that we know, that 2m upon h cross square, root e minus v upon root e plus root e minus v whole square, 2m upon h cross square, this will cancel. So what we got, this is root e minus v upon root e plus root e minus v whole square. And in the question, e is how much? E is given, wait, let's see. E is given 1 ev, and step potential v is given 0.75 ev. So we need to find put it in the formula itself. So e is 1 minus 1 minus 0.75, 1 plus 1 minus 0.75. Now you can all solve this. I have provided you all the values, and tell me what is the answer, huh? What is the answer? This will be 1 minus 0.75 is 0.25, 1 plus 0.25 whole square. So let me see, calculator. 0.25 is equals to 0.5. 0.5. So this one is 1 minus 1 minus zero point 0.5 upon 1 plus zero point 0.5 whole square. So this is zero point 0.5 and this is 1.5 whole square. Zero point 0.5 divided by 1.5 give 0.33. So 0.33 whole square is 0.33 into uh, 0.33. Ha, 0.33 into 0.33. It is ha point 0.1. 0.10. So this is the reflection. So this is the probability of its reflection from the barrier 0.11. Okay, because in the question you are asked to find out two decimal places. So that is why keep this small things in mind. Huh? If it is asked two decimal place, then you should write by two decimal place. I hope this is question is very clear to everyone. So they are in the question we are given energy and potential. Energy and potential value given is given in the question, but we should find out how to apply these value in the formula. So for formula you should solve the Schrodinger equation for this particular system. So I hope this question is clear to everyone. We'll move on to the next question. This question, actually I want everyone to at least try this question. This is a very straightforward question. Very straightforward question. I want everyone to at least try for 2 minutes, then I'll tell you. So in the question, consider a one dimension potential well of with this. There is a one dimension potential well is given to us whose width is 3 nanometer. Using the uncertainty principle, estimate the minimum depth of the well such that it has at least one bound state for an electron. So you have to do nothing. You know the formula of energy. Energy is p square by 2m, right? So how to find out this p momentum? So they are in the question it is given to us that you should find out the energy using uncertainty principle. This particle is here. Suppose this particle is electron. Okay, electron is given to us. So this particle electron is inside the well. So what is the delta x for this system? It will be a, right? Because this electron cannot move outside. So the delta x for this uncertainty in the position is itself a, and you know delta p is equals to h cross by 2 delta x. So delta p is equals to h cross upon 2a. Put the value of energy, sorry, delta p here, then this will become h cross square upon 8, 4a square 2m. So this will become h cross upon 8 m a square. Now you know h cross has the value h upon 2 pi. Put the value of h cross as h square upon this h square upon 4 pi square 8 m a square is equals to h square upon 32 pi square m a square, right? Now, if you put the value h cross, this is 6.6 into 10 raised to the power minus 34 square. This is 32 and this is 3.14 whole square, and this is ma 9.1 into 10 raised to the power minus 31, and a is 3. A is 3 given to us. 3 into 3 is 9, and it is given to us in nanometers. So 1 meter is equals to, sorry, 1 nanometer is equals to 10 raised to the power minus 9 meter. So it is 9 into 2 kitna, how much? It is 18. So 9 into 10 raised to the power minus 18. Solve this, you will get value in 1 MeV. So this is the answer. Clear everyone? This was a very straightforward question. So it was of 2 marks, and this was the, I guess this was the very easy question. Now I hope this one is clear to you. So I'll move on to the next question. You know the degeneracy of the third energy level of a three-dimensional isotropic quantum harmonic oscillator. This is again the same thing you have to do. There is a particle which is in this harmonic oscillator, quantum harmonic oscillator. Sorry, not particle. You have to find out the degeneracy of the third energy level of an isotropic quantum harmonic oscillator. So for the quantum harmonic oscillator, I'm not solving Schrodinger equation for it, but I'll directly tell you what is the energy and the wave, what is the energy and the wave function for this quantum harmonic oscillator. This is the Hamiltonian for this quantum harmonic oscillator. This is kinetic energy term, and this is potential energy term. Okay, and the energy for this particular system is n plus 1 by 2 h cross omega, right? In the first question itself, we have solved the particle in a square box for 2D, and we know how to solve when the particle is given to us in one dimension square potential well. Now again in this question, uh, relate this question with the first question that we have done today. So in this question we are asked in three dimension. So in three dimension again, your energy will become nx plus 1 by 2 h cross omega x plus ny plus 1 by 2 h cross omega y plus nz plus 1 by 2 h cross omega z. Okay, nx plus ny plus nz is equals to 1 plus by 1 by 2 1 by 2 n plus 1 by 2 h cross omega. You know why I have written h cross omega directly? Because omega x, omega y, omega z, they are three different terms. They are three different quantity now, but I have written omega for all three of them. Reason, because in the question itself it is given isotropic quantum harmonic oscillator. Isotropic means property will not change when we will change the direction. That means it is isotropic. So omega x, omega z, omega y is equals to omega. They all will be equal. If it is anisotropic, then omega x is not equal to omega y, is not equal to omega z. Okay, then we have nx plus ny plus nz is equal plus 3 by 2 is equals to h cross omega. In the question you are asked to find out the degeneracy of third energy level. So first energy level will be the ground state, n is equals to 0. Second will be n is equals to 1, and this is n is equals to 2 is third energy level, right? So how many ways are there to achieve n is equals to 2? How many ways? That will be decided by the value of nx, ny, and nz. Okay, I'll find out the way. So for n is equals to 0, there is only one way, 0, 0, 0. Only one. There is no degeneracy. For n is equals to 1, this is ground state. And for n is equals to 1, there are three ways. Nx is equals to 0, ny is 0, nz 0. I can also write it 0, 1, 0, and 0, 0, 1. So there are three ways. So three degeneracy. And for n is equals to 2, there will be 1, 1, 0, 1, 0, 1, 0, 1, 1, 2, 0, 0, 0, 2, 0. Then there will be 0, 0, 2. How many ways are there? Six ways. So degeneracy is 6. Clear? So the answer will be 6. This question is clear to everyone? I didn't get the question. Can you repeat it again? हाँ, हाँ, yeah, this formula can be easily n plus 1, n plus 2 by 2. There is a degeneracy formula for harmonic oscillator. N plus 1, n plus 2 by 2. This is a straightforward formula. If you put n is equals to 0 in it, so 0, 0. That means 1 into 2 is divided by 2 is 1. So there is no degeneracy. When n is equals to 1, put 1. 2 into 3 by 2, then there is degeneracy 3. So see, you can see 3 degeneracy. When put n is equals to 2, you have 3 into 4 by 2, 6. So degeneracy is 6. So it's a straightforward formula, but I have shown you like how to do it in a traditional way. But if in exam this question is coming, so you should memorize this formula for harmonic oscillator. N plus 1 by 2, n plus 2 by 2 by 2. This is the formula for harmonic oscillator in 3D isotropic to find out the degeneracy. Okay. I hope everyone enjoy the class today. So
Yes.
we will meet next week. Thank you, everyone.